All right, so let's talk about how we would find the 100th term in this sequence. We've realized using the recursive, which is what I've done here, is going to mean I'm going to have to keep going until I get to the 100th term and keep adding 5. And I don't want to do that. I mean, here I'm already at the 1, 2. I'm only at the 9th term. I've got 91 more times I have to add 5 to get there. So let's see if we could write it explicitly. Remember that our explicit formula is always the first term plus the constant difference times n minus 1. So a sub n would be the first term, which we know is 2, plus 5 times n minus 1. This would be explicit, as opposed to what I have up here, which is recursive. This would be explicit. I could also write this getting rid of the parentheses, 2 plus 5n minus 5, which is 2 and negative 5 is negative 3 plus 5n. So this is explicit, or this is explicit. And I want to find the 100th term. A sub 100 is 2 plus 5 times 100 minus 1, that would be 99. So I can use my calculator and do 2 plus 5 times 99, and I get 497. If I wanted to use this formula, a sub 100, negative 3 plus 5 times 100, which is negative 3 plus 500, which is 497. Either way, I get 497 as my 100th term, and I used my explicit formula. Okay, what we're going to be doing is we're going to be looking at a sequence. We're going to write its first term, its constant difference, the explicit formula, and the recursive formula. Okay. My first term is 2. If I look here, my constant difference is plus 5. And my explicit formula then is 2 plus 5 times n minus 1. My recursive formula, my first term is 2. A sub n is always the previous term plus 5. I want you to notice that when we're doing a recursive formula, the first part of it always looks like that. Of the second line, it always starts off a sub n equals a sub n minus 1. That's a sub n equals previous term plus 5. That's how you think of that. All right, let's go to the next one. My first term is 18. And I'm subtracting 6, so minus 6. So I'm going to have 18 minus 6 times n minus 1. My first term is 18. A sub n is always the previous term, which is a sub n minus 1. Always starts off that way, minus 6. So what you're going to do now is you're going to fill out this worksheet, and you're going to be doing the same thing as what I just did at the bottom of that last page, where you're going to fill in this entire table. Let's see, why don't I just do a couple? I'll do 3 and 6 and 8 with you. All right, number 3. First term is 5. Looks like here I added 21. And then here I added 21. Yep, I keep adding 21, so plus 21. So my explicit formula is a sub n equals the first term, excuse me, plus 21 times n minus 1. Notice I've got these up here as a guide if I need them. Recursively, the recursive formula always has two parts. First term is 5. A sub n is the previous term. Notice this, by the way, should say a sub n, not a sub 2. Always looks like that. Always looks like that. Always starts that way. Plus 21. Okay. Let's try number 6. My first term is negative 8. I'm going to do my explicit. It's negative 8. I keep adding 2, so plus 2 must be my constant difference times n minus 1. First term is negative 8. The constant difference is plus 2. So the first, it looks like 1, 2, 3, first 4 terms would be negative 8, negative 6, negative 4, negative 2. Okay. Number 8, I'm given the explicit formula, which means my recursive formula, the first term must be 53. The nth term is the previous term. Remember, I always start off that way. It says my constant difference is minus 7, so subtract 7. So the first term is 53. My constant difference, I'm subtracting 7. So my first term is 53. When I subtract 7, I get 66. When I subtract 7, I get, I added 7. Actually, I didn't add 7. I meant to write 46. Sorry about that, because I'm taking 53 and then subtracting 7. Then I get 46. I subtract 7. And I get 39. I subtract 7. And I get 32. Sorry. And then for 9 and 10, we're going to use the explicit formula to find the 40th term. So simply let n equal 40, and you'll be able to find that 40th term. All right, so for the lesson master, I'm not going to do all of them, but you're asked to identify the formula as either recursive or explicit, find the first 4 terms, and then find the 10th term. Well, whenever it's 2 parts like this, like first term and nth term, first term, this really should say n. I don't know why they keep doing that. First term and nth term, when it's written like that in 2 parts, we know that it has to be recursive. So when I look at these, I know this is recursive. This is written in 2 parts. This must be recursive. This one as well. And this one. Because it's written in 2 parts. First term and the nth term. All right, let's go ahead and we'll do number 1 together. Find the first 4 terms. So the first term is negative 3. That's easy to find the first one. And it says we're supposed to take the previous term, r sub n minus 1, and multiply it by negative 2. If I multiply this by negative 2, I get 6. If I multiply that by negative 2, I get negative 12. If I multiply that by negative 2, I get 24. Now, since this involves multiplying, I don't think I can just use this to figure out my explicit formula, not with what we've learned so far. So I'm going to just have to keep going. That's my 4th term. So my 5th term would be negative 48. And then I'd have positive 96. And then negative 192. I'm just using my calculator and times negative 2. And I get 384. So 4, 5, 6, 7, 8 times -2, -768. I just want to show you, all I'm doing is on my calculator, I'm just multiplying by -2 times -2, and I get 1,536. And that was 4, 5, 6, 7, 8, 9, 10th term. So sometimes you have to do that kind of work to get to that 10th term. Let's do another one together. How about number 3? Says my first term is 0.7. And then I'm supposed to take 3 times the previous term and subtract 0.3. So I'm going to take 3 times the 0.7, because that's my first term. And then I'm going to subtract 0.3. And I get 1.8. Okay. It says take 3 times the previous term, which is 1.8, and subtract 0.3. And I get 5.1. And take 3 times the 5.1 and subtract 0.3. And get 15. And I'm just going to keep doing this and taking 3 times 15 and subtract 0.3, and I get 44.7. 3 times 44.7 minus 0.3, and I get 133.8. 3 times the 133.8 minus 0.3, and I get 401.1. 3 times the 401.1 minus 0.3, and I get 1,203. 3 times the 1,203 minus 0.3, and I get 3,608.7. Let's see, 4, 5, 6, 7, 8, 9. This is my last one. 3 times 3,608.7 minus 0.3, and I get 10,825.8. So that's all I just have to keep multiplying by 3 and subtracting 0.3 by the previous term. Let's see. We should do any others. We can go ahead and maybe do number 5 together. Number 5 says take the previous term and square it. So I've got 5, and then I'm going to have 5 squared, and then that would be, when I square that, that would be 5 to the 4th, and when I square that, that would be 5 to the 8th, because power to a power you multiply, or if you think of it this way, 5 squared is 25, and then 25 squared is 625. And then 625 squared is 390,625. Square that number. Oh wow, that's really big already. And then I'm going to square the next term. So this would be 5 to the 16th. Let me see if 5 to the 16th. Yep, it's that number. So then this, see, I had a feeling this was going to happen. This means times 10 to the 11th. That's going to be a really large number. So then I'm going to do 5 to the 32nd.